Hello, students. Hopefully everyone's doing well today. Today, we are going to be working on balancing chemical equations. So let's just get down to the nitty gritty right away. This right here is a chemical equation. So what's a chemical equation? Well, a chemical equation is made up of a bunch of different parts. So it's kind of like a mathematical equation where it says 1 plus 2 equals 1 plus 2. This is the gist of what it is. And that little yield sign is kind of like an equal sign. So these, and I highly suggest you guys take notes. You might want to pause and take notes. These guys over here, these are called the reactants. All right? Those are called the reactants. Reactants are what react or mix together in a reaction, right? This is what you have that is causing, well, they're reactants, okay? It's the things that mix together, all right? The other side, we call these the products. The products are what are getting produced. So the products get produced. So reactants react together, products get produced or get made. This little sign in here, this is known as yield. So we might read this equation as CH4 reacts with oxygen to produce or yield, right here, to yield or produce carbon dioxide and water. That might be how I say this equation, all right? So reactants are what we start with, products are what we end with. At the end, in a perfect reaction, the reactants are gone, and all you're left with is products. In a perfect reaction, you don't start with any products, you just start with reactants. So we also have some other things. We add or sum when we're doing a reaction. So we add these together. We add those together by saying, hey, that is what's in the box at the end. This is what's in the box at the beginning. All right, coefficients. These numbers in front, just like in mathematics, those numbers are called coefficients. What that means is the number of whatever it's in front of. For example, this is called methane, okay? So this means you have one methane. So if there's a box right here, right? Let me pause this really fast. So if we're going to put these in boxes, what these coefficients mean, these mean the number of these items. For example, this is methane. So this would be the box that we're starting with. So this is like the beginning over here and what we end with. So what we're going to start with in the box is one methane molecule and two oxygens. So you can see we have one methane and two oxygens in the container to start with. The finished product, you would end up with one carbon dioxide molecule, and here's the one carbon dioxide molecule, and two water molecules. So at the end, what's in the box? Well, none of the methane and oxygen is in the box anymore because it all got used up. So is there carbon dioxide or water in the box at the beginning? Absolutely not, because it hasn't reacted yet. So we start with this, we end with the products over here. All right, now, very quickly, I'm going to talk to you about what a formula is and a subscript. So formula, let's just take this as H2O. It's very important that you understand that if you take H2O and you're like, oh, I'm going to put a 4 there, you can't do that because it's no longer H2O. This is a completely different compound. What you have to do is if you want to increase anything, you can say, well, you just can't mess with these coefficients because it changes the compound. But if you want to have more than one water, you can say, I want 2 waters, which means you now have 2 of these H2O molecules. I highly suggest you rewind the screen and understand what this means. The coefficient tells you how many of those you have, all right? You'd have 2 water molecules. So we've talked about this before, but I'm going to review it because I understand that some people struggle on it. if we have the molecule MgOH2 or magnesium hydroxide, that means we have one magnesium attached to two hydroxides, okay? So you'd end up with two hydrogens and two oxygens attached to this magnesium. If we take a coefficient and we put a 3 in front of it, we're basically saying we're going to take 3 of those molecules. So now we would have 3 of these MgOs. So however many oxygens we started with, which would be 2 of those, which would be 2 on each, that means we now have 6 oxygens total, because you can see you have magnesium hydroxide, magnesium hydroxide, magnesium hydroxide. 1, 2, 3, 4, 5, 6. So you might want to take the time to practice this on your own to get a better feel for it. But this is the information you're going to need. You're going to have to understand that 3 would mean you have 3 magnesiums. You already have 2 oxygens in each molecule, which means this would be 6 oxygens, and you would also have 6 hydrogens. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. How many magnesiums? 3. 1, 2, 3. So I'm going to move into the law of conservation of matter. So we have the same balanced chemical equation. What the law of conservation of matter says is that however many atoms you start with, okay, which would be on the reactant side, you will have the exact same number of elements on the product side. So nothing is gained and nothing is lost. Whatever you start with, you have to end with. And this works with individual numbers of atoms as well as with mass. If you start with 50 grams of stuff, you will end up with 50 grams of stuff. A balanced chemical equation, which is what this is, where everything's balanced and equal on both sides, obeys the law of conservation of matter. If, ladies and gentlemen, I do not have a balanced chemical equation, which you can see right here, those all just have 1s in front of them because I didn't put any coefficients there, then this equation will not be balanced. Only a balanced chemical equation follows the law of conservation of matter. I'm going to quickly show you how this works out with this with the next example. So with this example, what I want to do is show you what balancing is. Remember, these are the reactants and these are the products. It's basically 2 different sides. Now, in balancing reactions, there are probably 10, 20 different ways to balance these. I have my system. Other people on the internet have their own system. Different teachers have their own system. I'm going to show you 2 systems, okay? So first thing we want to do, and this one is already balanced for us. I'm just going to prove that to you. What we want to do is we want to say, do we have the same number of carbons on the reactant side as we have on the product side? So we're going to say, well, I have carbons, I have hydrogens, and I have oxygens. And over here, I have carbons, I have hydrogens, and I have oxygens. So all we do, it's just a game about counting. I'm going to start with the carbons first. How many carbons do I have? Well, I have 1 CH4 molecule, okay? So I have a CH4 molecule, okay? Oops, I didn't want to do that. A CH4 molecule. So I have 1 carbon with 4 hydrogens. I also have 2 oxygen molecules, and that's going to be an oxygen attached to another oxygen and an oxygen attached to another oxygen, all right? On this side over here, I have 1 carbon dioxide molecule, which means I have 1 carbon and 2 oxygens, and then I have 2 water molecules. And here are my 2 water molecules, all right? There's my 2 H's and my O. So we're just going to start adding. So on the reactant side, how many carbons do I have? I have 1 carbon, 1 carbon. Boom. How many hydrogens do I have? Well, I have 1 methane molecule, and each methane has 4 hydrogens, so I have 4 hydrogens. And then how many oxygens? I have two O2 molecules. So this is an O2. That's another O2. So I have 4 oxygens. Let's look and see if I have the same number on the other side. How many carbons do I have? Well, I have 1 CO2 molecule. So I have just 1 carbon. How many oxygens do I have? Well, I have 2 oxygens right here, right? And well, it doesn't balance, but we're not finished yet. How many hydrogens do I have? Well, I have 2 water molecules, and each water molecule has 2 hydrogens, okay? But I also have 2 oxygens. So it looks like I have 1, 2, 3, 4 oxygen molecules. So I don't have 2, I actually have 4. 1, 2, 3, 4, which balances out perfectly. The reactants are going to add together, which it's a very simple, it's an elementary process of adding things together. The complicated part is just how do you know how many of each thing you have? All right, most people are going to get this relatively quickly. And then others, if you're not sure about what the 2 means, you're going to struggle a little bit. All right, but if I can help explain to you what the subscripts and everything mean, you're going to understand it a little better. So that is in the gist what balancing is. Make sure you have the same number on the left as you have on the right. Okay, so in order to balance chemical equations, there's a couple of rules. Number 1, a couple of things to help you out with. First rule, ladies and gentlemen, you only change the coefficients to balance. What does that mean? Well, you only change the number that's in front of these compounds or elements, all right? So you only change the coefficients. You may never, ever change the subscript. So you can't be like, I need another hydrogen. I'll just put a 3 right there and we'll turn water into H3O. We can't do that because the formula for water is H2O. You also need to always include the number 1. So if the formula comes out with a 1, 1, 2 or something to that effect, you must put in the 1s. And lastly, we'll work on it. Polyatomic ions, it's easy. A polyatomic ion would be something like carbonate. So if you have something to the effect of tungsten 4 carbonate, all right, you can take that polyatomic ion and just say, I have 2 carbonates. So instead of adding up the individual carbons and the individual oxygens, you take this as a unit, okay? But those are rules we'll get to as we go. So let's just start off. First thing first, when balancing, you just want to balance back and forth. Remember, there's our line right there going down the middle. That's our equal sign. So we want to make sure that the reactants are equal to the number of products. So let's start off. How many hydrogens do we have in water? We have 2 hydrogens. Perfect. Now we're going to go to the other side and check how many hydrogens do we have? How many hydrogens do we have over here? We've got 2. Sweet. The hydrogens are balanced. Let's go to the next element. I usually will start at the first element and just balance. Are they the same on the left as the right? Next, we have oxygen. How many oxygen atoms do we have? We have 1 oxygen atom here. How many oxygens do we have on the other side? We have 2 oxygen atoms. Those are not balanced. So I need to make sure that I turn the number of oxygens the same. And you can only do that by adjusting the coefficient. So I'm going to put a 2 in front. I'm going to say, I'm going to now take 2 water molecules. So now I have 2 oxygens. And over here, I have 2 oxygens. Now, perfect. But there's a problem, is that now that we've changed the coefficient, we've thrown off the number of hydrogens. But we can just fix it by changing the coefficient here. So we have 2 hydrogens in the water, but there's 2 water, so we have 4 hydrogens. We need to have 4 on this side, so we'll put a 2 there. So 4 hydrogens, 4 hydrogens. We have 2 oxygens. We have 2 oxygens, and that's our balanced chemical equation. Mr. Pepic, show us. I will. So there's H2O. There's H2O, right? Because I have 2 water molecules, and they can only come in these packages. And then I have 2 hydrogens, because these are hydrogens packed together. So I have hydrogens packed together, right? And then I have oxygens. Then I have 1 oxygen in a group of 2. So let's count. 1, 2, 3, 4 hydrogens. 1, 2, 3, 4 hydrogens, perfect. 1, 2 oxygens, 1, 2 oxygens, and we're balanced. So here's our next example. So our next example, I'm going to add some more visuals for you, okay? So again, there's our equal sign or our yield, all right? And we want to balance these out. So another way to do it is to start off and say, okay, let's start off with the hydrogens, and then we have nitrogens, and we must have the same elements on the other side due to the law of conservation of matter. Mr. Pepe, you put those in opposite order. You know what? Let me fix that. Okay. So, and you have how many hydrogens and how many nitrogens. So let's just start off. How many hydrogens do we have? We have 2 hydrogens. How many hydrogens do we have on this side? We have 3 hydrogens. Those don't balance out. On this side, we have 2 nitrogens. And on this side, we only have 1 nitrogen. So we're going to have to figure out how to balance. Now, my suggestion is you just start anywhere, all right? But if you take a look, you can say, well, if we take a look, which one looks like it's going to be able to work? Well, let's take a look at the hydrogen. We have 2 here and 3 there. That seems confusing. All right, so now I have 2 here and 1 there. So how can I get 2 nitrogens on this side? I can just put a 2 on that line. So now I have 2 NH3 molecules. So I'll show you what we have. We have 2 NH3 molecules. Now, all right. Now, oops. Now, if I have 2 NH3 molecules, you want to say, well, how many nitrogens do I have? Well, now I have 2 nitrogens. How many hydrogens do I have? I no longer have 3. I now have 6 hydrogens. Okay, so now let's see if we can do the same thing over here. The nitrogens are balanced. Look, I have 2 and 2. So don't mess with the nitrogens. But I have 6 hydrogens and only 2 hydrogens. So how can I multiply this out to get to 6? Well, I can multiply this by 3 because 3 times 2 equals 6. Mr. Pepe, draw it for us. Sure. I have 1 N2 molecule and I have 3 H2 molecules. So I have 6 hydrogens and 2 nitrogens. I have 6 hydrogens and 2 nitrogens. All that happens due to the conservation of matter is these atoms just rearrange themselves on the other side. But the balancing has to come in to make sure that the same number is present. Now, we're not done because I want you to put a 1 right there. So every single compound or element has a coefficient in front of this. So the balanced chemical equation would be 3 hydrogens plus 1 nitrogen, well, this is called nitrogen, yields 2 NH3 molecules or 2 ammonias. All right, let's try this next one. Again, this is where you have the products and the reactants. So you can start off here and say you've got how many N's, how many O's, how many N's, how many O's. I normally don't do it this way. I usually just bounce back and forth, but I'm trying to change it up to give you better visuals because I can't give them to you in class. All right. So this right now, these nitrogens are coming in packages of 2. So right now I have 2 nitrogens. I have 2 oxygens. Over here I have 2 nitrogens, which is good. Those are balanced. And here I only have 1 oxygen. Well, I need to increase the amount of oxygens on this side. And I can't go, oh, let's put a 2 there. Not allowed to do that. You have to only put coefficients. So just let's double that thing up. So let's put, and I'll change the color to red. I'll put a 2 in front. So what does that do? Well, now that gives us 4 nitrogens because you're multiplying it out and 2 oxygens. So now the oxygens are balanced, but the nitrogens are not balanced. So how can we balance the nitrogens? How can I get 4 on each side? Well, just put a 2 there. 2 times 2 equals 4. 4 nitrogens, 2 oxygens, 2 oxygens, and we're balanced. It's this simple. You just bounce back and forth, bounce and forth. Now, there are examples that are brutal, but I'm going to hold off on that till day 2. Now on this example, what we're now working with, and some of you see them better than others, but you can see we have this polyatomic ion right here. We have this polyatomic ion, all right? And we're gonna treat that as one unit. So here we have our line going straight down, right? There's a line going straight down, whoops. And then let's take a look at what we have. So we have a magnesium. We have chlorine. We have, see this thing right here? This is a polyatomic ion as well. That's ammonia, okay? So we have an NH4. And then we also have nitrate, which is NO3. And the faster you recognize that, the easier your life is gonna be, because you treat that as one packet, okay? Here's my chlorine. Here's another NH4 on the other side. And here's a nitrate. So let's play it out. How many magnesiums do we start with? We have one magnesium. How many chlorides do we have? Sorry, we have two chlorides. How many ammonias, this whole packet? We have one of those and one of those. All right, one nitrate. Let's go to the other side. I have one magnesium. I look at the whole thing, I have one chlorine. I only have one ammonia, but on this side I have two nitrates. And what we need to do is we need to try and balance those out. So right away, we can look and say, well, here's a one and here's a one and a one. So those are even. Don't mess with the magnesiums if we can, all right? So now we take a look at the chlorines. And right away you say, okay, there's twice as many chlorines over here, so we have to double the number of chlorines. The only way to double is to put that number right here. And now I've just multiplied that one and made two chlorines. But I've also doubled the amount of ammonias, and I also have two ammonias over here, all right? So now let's look at the other side. All right, so we have one magnesium, two chlorines, and now it looks like my ammonias are out of whack. And my nitrates are out of whack because I have a 2-to-1 ratio. So let's see if I can double the numbers of ammonia. I double the numbers of ammonia by putting a 2 there. That means two ammonias. But in, oh man, my pen. But in doing so, I've also doubled the amount of nitrates, which it's perfect because that's exactly what I needed. So a 1 to 1, a 2 to 2, 2, 2, 2, 2. And then I just add ones all the rest of the way across. And we do that so when I give you answers, I'll be able to say, okay, the answer is a 1-to-1-2 ratio, right? A 1-to-1-2 ratio. Hopefully I'm making this clear and you're sitting there going, oh my God, I see it. If you don't, I've got some more examples for you. All right, so let's take a look at this next one here. All right, so this next example, ladies and gentlemen, it's very similar, all right? We're gonna look at it right away and say, okay, here's my halfway point. These over here are called my, reactants. These over here are called my, my products. And if we look, we can say, okay, we've got hydrogen. And then we have SO4. If we want, we can break those apart, but start recognizing that sulfate. So I have an SO4 on this side, and you look and you say, yeah, look, there's the SO4 on the other side, right? We also have an Mn, known as a manganese. And it looks like those are the only little packets. Now, yes, if you want to break the oxygens apart, go have fun. It's just going to make things more complicated for you. So I suggest keeping your polyatomic ions together. So you also have hydrogens over here and manganese over here. How many hydrogens do we have? Look at the whole thing. We have 2. How many sulfates do we have? We have 1 sulfate. We have 1 manganese. Over here, we have 2 hydrogens. How many manganese do we have? 2. How many sulfates do we have? We have 3 sulfates. So right away we can sit there and go, okay, I can see that I have 3 times more sulfates on this side, a 1-to-3 ratio, which means I need 3 times that over here. So what am I gonna do? I'm gonna come in and I'm gonna say, this is just how Mr. Pevig does it. You can do it any way you want to, right? Your hydrogens are balanced, sulfates are not balanced, so we're gonna need to put a 3 here. So what does that mean? That means we now have 3 sulfates. But don't forget, in changing the number of sulfates, we just changed the number of hydrogens. So 3 times 2 equals 6. But we're not going to worry about it because we balanced the sulfates. We're happy. Let's do one thing at a time. Now let's take a look at the manganese. How many manganese do we have? Well, I have 2 on this side, and I have 1 on this side. So how can I get more? Well, I'm going to double that. I'll multiply that by 2. 2 times 1 equals 2. Well, it looks like the hydrogens are off. Well, I have 6 hydrogens on the reactant side, 2 hydrogens on the product side. How can I multiply 2 to get a 6? So what would I do? I'm going to multiply that by 3, because 3 times 2 equals 6. And now I have 6 hydrogens, 3 sulfates, and 2 manganese. Ladies and gentlemen, it's just going pop, oops, and then I have to write in right here. I don't want to change this, so I need to put a 1. All right, so all we're doing, we're just balancing equations all the way through, okay? So I think that's going to end my lecture for today. If you have any questions, I mean, it just gets more and more, but maybe I'll just do this last one, okay? We'll see what happens. All right, so we have this right here. All right, ladies and gentlemen, now at this juncture, what we're doing is we're going to balance this equation. It's going to be very similar. So we can say we have carbons, we have hydrogens, and we have oxygens. And you can see that we don't have any polyatomic ions. We have carbons, hydrogens, and oxygens. So how many do we have? We're starting off with 5 carbons. We're starting off with 12 hydrogens. We're starting off with 2 oxygens. We're starting off with 1 carbon, 2, okay, hydrogens. And if you take a look, we have 2, 4, 3. So it looks like our oxygens are spread between 2 things, which makes it tough. So we're probably, since there's oxygens in more than one place, we're going to want to do the oxygens last. All right? Because if I double the oxygens here, that changes everything. So in this case, since we have an atom that's in 2 different locations, we'll do it last. So let's start off. How can I balance the carbons? I have 5 and 1. So I need to multiply this one over here by 5. Correct? So now, whoops, let me change that color. So now I have 5 carbons. The carbons are balanced. But in changing this, I've just changed the number of oxygens, which means now I have 11 oxygens. Oh no, don't worry about the oxygens till the end. All right? So are the carbons balanced? Yes. Let's take a look at the hydrogens. I have 12 hydrogens over on the reactant side, right? And I only have 2 over on the product side. So how can I multiply and turn 2 into 12? Multiply by 6. So I'm going to multiply this by 6. I'm going to turn that into 12. So now my carbons are balanced. My hydrogens are balanced. But now let's just take a look and let's see if we can balance and figure out how many oxygens we have. 5 times 2 equals 10. So right here, I have 10 oxygens. 6 times 1 equals 6. So now I have 16 oxygens. No big deal. How do I turn a 2 into a 16? 2 times what equals 16? You're going to say 2 times 8. 2 times 8 equals 16. So now we have 5 carbons and 5 carbons, 12 hydrogens and 12 hydrogens, 16 oxygens and 16 oxygens, and we're stoked. We're like, yes, we have a 1:856 ratio. This is our balanced chemical equation. Ladies and gentlemen, I'll be here all day long. Give me a holler if you have any questions. And that's it. I hope you have a great day. Good luck.